Welcome to our latest video on the topic of alcohols, uses, nomenclature and classification. This video is suitable for AS and A-level students. By the end of this video lesson, you should be able to explain how ethanol can be made from sugars using yeast in a process called fermentation. You should also be aware of the uses of ethanol as a fuel in alcoholic drinks and as solvents. And finally, you should be able to use the IUPAC rules to name and draw the structural formula of alcohols and be able to classify the alcohols as either primary, secondary or tertiary. Now, alcohols are another important family or homologous series of organic compounds just like alkanes, alkenes and halogenoalkanes, which we've studied previously. Now, in alcohols, there is an OH functional group. Remember, the functional group is the part of a molecule that determines its chemical reactions. And this OH group is what makes an alcohol different from an alkane. Now, alcohols have the general formula CnH2n plus 1 OH. And the first two members of the alcohol family are shown here. Methanol has a formula of CH3OH and ethanol is C2H5OH. Now, alcohol can be made in a process called fermentation. Anaerobic respiration in microorganisms such as yeast is used in wine making and bread making. And anaerobic respiration takes place in the absence of oxygen. So these microorganisms are able to respire without oxygen. And we make use of this to make alcohol. Now, this process is called fermentation. And in fermentation, the yeast converts glucose, it converts sugars, into carbon dioxide and alcohol. And the alcohol that's produced in fermentation when you use glucose is ethanol. So this picture summarizes the process. Sugar, with the help of yeast, in the absence of oxygen, makes carbon dioxide and alcohol. And the alcohol we're going to make is ethanol. Now, the alcohol that you produce in fermentation can be obtained from the reaction mixture by using distillation. And the yeast contains enzymes which speed up this fermentation process. And the enzymes are catalysts produced by living cells. And enzymes are being increasingly used by chemists to speed up chemical reactions. Now, this form of science is called biotechnology. So if we look at the equation here, we have glucose, our sugar, being converted by the yeast. And remember, yeast is a fungus that contains an enzyme which speeds up this fermentation process, and it changes to ethanol and carbon dioxide. So we have C6H12O6 and it goes to 2 C2H5OH, 2 molecules of ethanol and 2 carbon dioxide molecules. Now, to carry out a fermentation experiment, you need a glucose solution. You need glucose mixed with water. You also need yeast, because yeast contains the enzyme that speeds up fermentation. And remember, yeast is a microorganism that is able to respire anaerobically. And it's the respiration process that produces alcohol in the form of ethanol and carbon dioxide. You also need a warm temperature, around about between 25 and 35 degrees C. And finally, you need a pH of between about 4 and 7. And if you have these conditions, these are the optimum conditions for fermentation to take place. Now, temperature is crucial for fermentation because fermentation relies on enzymes. And at low temperatures, enzymes are inactive, they don't work very well. And at high temperature, because an enzyme is a protein, it unravels, it becomes denatured. So therefore, fermentation works best between around 25 degrees C and 35 degrees C. And if you go a much higher temperature than that, the protein will denature, will unravel, and you go at a much lower temperature, the enzyme's inactive. So that's why temperature is really crucial. Now, fermentation often takes a couple of weeks, and after the fermentation process, you have to remove the yeast. So the yeast has to be filtered, and to get the alcohol, you distill the reaction mixture. And that's why you may have heard that alcohol is made in a distillery, because distillation is a key part of the production of making alcohol. Now, fermentation is a batch process rather than a continuous process. And in a batch process, we have a sample of sugars, a batch of sugars, that are fermented in the right conditions with yeast, a temperature around about 30 degrees C, an absence of oxygen, a pH between 4 to 7, and they're left to ferment over the few weeks. And once they've fermented and made our alcohol, the process then starts all over again. So it's a stop-start process. Now, an alternative to fermentation is to make alcohol from alkenes. And this is a continuous process. I can make alcohol this way 24 hours a day. And the alkene is reacted with steam under high pressure and temperature, and you get an alcohol. Now, an advantage of making alcohol from alkenes, as I said, is it's a continuous process. So you are able to make alcohol 24 hours a day, and economically that's very good if you're running a business to produce alcohol. But a disadvantage is you're making the alcohol from crude oil, because alkenes come from crude oil, and crude oil is a non-renewable resource. In contrast, making alcohol through fermentation of sugars is a renewable process, because sugarcane is grown to produce sugar, and once you've cut it down to make your alcohol, you can just plant some more. So it's a renewable resource. It's not a non-renewable resource like oil, which takes millions of years to form. So we're now going to turn our attention to the uses of alcohol, and specifically the uses of ethanol. Now, you need to know for the exam that ethanol is used in alcoholic drinks, is used as a solvent, and it's used as a fuel. Now, this slide shows the different amount of ethanol, alcohol, that's present in popular drinks. Now, the idea of counting alcohol units was introduced in the UK in 1987 to help people keep track of their drinking. And units are a very simple way of expressing the quantity of pure ethanol in a drink, because 1 unit equals 10 milliliters or centimeters cubed of ethanol. Now, it's recommended that both males and females do not consume more than 14 units of alcohol a week. That is the healthy limit. That is the recommended limit. And this has changed recently, because previously it was 21 units for a male and 14 units for a female. However, the new healthy limits are 14 units a week for both males and females. Now, even though drinking small amounts of alcohol has found to have positive health benefits, such as being good for your heart, alcohol misuse causes serious damage to your health. It can cause heart disease, high blood pressure, liver damage, strokes, and other serious health conditions. And this slide illustrates some of these. Now, in addition to the use of ethanol in alcoholic drinks, you should also be aware that ethanol is used as a solvent and as a fuel. Now, ethanol is a very good solvent as it dissolves many substances that are not soluble in water. It also evaporates quickly and is used as a solvent in glues, paints, varnishes, perfumes, printing inks, and deodorants. In the exam, you may be asked for a use of ethanol, and it's important that you mention that it's used as a solvent rather than saying it's used as glue or paint. Now, concern over the enhanced greenhouse effect is encouraging people to seek out alternative fuels, such as biofuels, and Brazil is the leading country using ethanol as a biofuel, where plentiful sugarcane provides a renewable source and lack of oil resources mean that imported oil is expensive. Now, alcohols are often used as fuels because when you burn them, they release lots of energy. And alcohols react with oxygen on burning to produce carbon dioxide and water alongside this energy. So here's an equation to represent this. Ethanol plus oxygen goes to carbon dioxide and water. Now, the advantages of bioethanol is it's made from sugarcane, which is a plant, and it's a renewable energy source. And secondly, even though carbon dioxide is produced when the alcohol burns, and carbon dioxide is a greenhouse gas, plants take in carbon dioxide, so the process is considered to be carbon neutral. Because although you're burning ethanol, which is producing carbon dioxide, you are growing sugarcane to make the ethanol, and the sugarcane is a plant, and that takes in carbon dioxide. Now, the disadvantages of using bioethanol is that it's land intensive to grow sugarcane. It takes a lot of farmland to grow sugarcane to make ethanol. And if you devote a lot of farmland to growing sugarcane, less is available to actually grow food crops to feed your population. So being land intensive is a disadvantage of bioethanol. And ethanol is less efficient than fuels such as petrol. And this means that there's less energy produced if you burn the same amount of ethanol compared to petrol. And the third disadvantage is you need a specific climate to grow sugarcane. Not every country has this climate. In addition to these disadvantages, there are two more that you should be aware of. Growing crops suitable for biofuels needs large quantities of water and fertilizers, and the use of water can strain local resources, and the use of large quantities of fertilizers to grow the same crop year after year can also cause water pollution. So that's one disadvantage you should be aware of as well. Now, one of our advantages was the fact that this process can be considered to be carbon neutral. However, there are question marks over this, especially when you have to transport raw materials and you have to transport products and you have to build factories that run on fuels. Question marks arise over whether this is truly a carbon neutral process. So this question mark over carbon neutrality is another disadvantage. So now we're going to focus on how we name and classify alcohols. Now, alcohols are named according to the IUPAC system. Now remember, IUPAC stands for the International Union of Pure and Applied Chemistry. So the first step when naming an alcohol is to select the longest carbon chain containing the OH group, and then you derive the parent name of this alcohol by replacing the E ending of the alkane with ol, i.e. ethane becomes ethanol, propane becomes propanol. So after you've selected the longest carbon chain, you then have to number this chain, and you start numbering at the end nearest the OH group. And step 3 is you number the substituents according to their position on the chain, and you write the name listing the substituents in alphabetical order. Note that the position of the OH group in the carbon chain is indicated by giving it a number which precedes the suffix ol of the alcohol. So if the OH group is on carbon 2 of a 3 carbon alcohol, that would be called propan-2-ol. And if it's on carbon 3 of a 5 carbon alcohol, that would be pentan-3-ol. So the best way to understand the rules for naming alcohols is to actually look at some examples. So my first example, I have a 4 carbon chain and an OH group on the end, carbon. So I'm going to number the carbon starting at the end nearest the OH group. So I'm therefore going to number this alcohol right to left. And my OH group is on carbon 1, and it's a 4 carbon alcohol. So the name of this alcohol is butanol. And in my second example, I have a longest chain of 5 carbons. I number this chain at the end nearest the OH group. So this time I'm numbering left to right. My OH group is on carbon 2, so it's going to be called pentanol. And on carbon 2, I have a CH3 group, and this is a methyl group. So this alcohol is called 2-methyl pentanol. So now we like to test your understanding of naming alcohols with some practice questions. So here are the first 2 alcohols we'd like you to have a go at naming. So pause the video, have a go at naming them, and then we'll go through the answers. So let's go for the answers to the first 2 questions. So the first alcohol is called 2-methyl propanol. This is because there are 3 carbons in the longest chain that contains the OH group. So therefore it's propanol. The alcohol group is on carbon 2, so it's propanol. Also on the second carbon is a CH3 group. So this alcohol is called 2-methyl propanol. Now for question B, the alcohol here is called 3-chlorobutanol because there's 4 carbons in the longest chain that contains the OH group. I number this chain at the end nearest the OH group, so I'm numbering it right to left here. The OH group is on carbon 2, so that's why it's butanol. There is a chlorine on carbon 3, so this alcohol is called 3-chlorobutanol. So here are the next 2 alcohols we'd like you to have a go at naming. So once again, pause the video, have a go at naming them, and then we'll go for the answers. So alcohol C here is called hexantriol. Now this is because the longest carbon chain that contains the OH group is 6 carbons long, and I've numbered the carbons here, and I've started at the end nearest the OH group, so I'm numbering right to left here, and the OH group is on carbon 3, and therefore this alcohol is called hexantriol. Now if we look at alcohol D, there are 4 carbons in the longest chain, and the OH group is on the end carbon. So I number the chain nearest the OH group, so I'm going to number right to left. So this alcohol is going to end in butanol. Now this alcohol also contains a chlorine on carbon 1, and it contains methyl groups on carbons 2 and 3. So therefore, I put the substituents in alphabetical order. So it would be 1-chloro, 2,3-dimethyl butanol. So here's the last 2 alcohols we'd like to have a go at naming. So once again, pause the video, have a go at naming these 2 alcohols, and then we'll go for the answers. So now let's have a look at alcohol E. Now this is the most complicated alcohol we've had a go at naming so far. So there are 5 carbons in the longest chain that contains the OH group, and if I number the carbon chain, I start at the end nearest the OH group, so I'm numbering left to right. The OH group is on carbon 2, so this alcohol is going to end in pentanol. Now we have a bromine on carbon 5, and we have a chlorine on carbon 5 and carbon 2, and a methyl group on carbon 3. So I have to put these substituents in alphabetical order. So it would be 5-bromo, 2,5-dichloro, 3-methyl pentantool. Now remember, di doesn't count alphabetically as a D, it counts as a C. So that would be the name of this alcohol. 5-bromo 2,5-dichloro 3-methyl pentantool. Now F is easier to name. The longest chain is 3 carbons long. I number the chain nearest the OH group, so I'm going to number left to right here. The OH group is on carbon 1, so it's going to end in propan-1-ol. And I've got a chlorine on carbon 3 and a methyl group on carbon 2, so this alcohol is called 3-chloro 2-methyl propan-1-ol. So now that we understand how to name an alcohol, the next thing to learn is how to classify one. And classifying alcohols is very similar to the way we classified halogenoalkanes. And we use the term primary, secondary and tertiary. And this is dependent on the number of alkyl groups that are bonded to the carbon attached to the functional group. And in this case, the OH group. So primary alcohols have one alkyl group on the carbon next to the OH. And secondary have 2 alkyl groups on the carbon next to the OH, and tertiary have 3 alkyl groups on the carbon next to the OH. So let's look at an example. Here we have ethanol. Now ethanol has a methyl group attached to the carbon next to the OH and 2 hydrogens. So as it has one alkyl group on the carbon next to the OH, it is classed as a primary alcohol. Now classification is particularly important for alcohols because primary, secondary and tertiary alcohols do have some different reactions. So therefore it's important you can recognize what type of alcohol you have, whether it's primary, secondary or tertiary. So we're now going to test your understanding of primary, secondary and tertiary alcohols with some practice questions. So pause the video and have a go at the first 4 alcohols and decide whether they're primary, secondary or tertiary. So let's go for the answers. So alcohol A is classed as a secondary alcohol because there's 2 alkyl groups on the carbon next to the OH and I've circled them. And alcohol B is classed as a primary because there's only 1 alkyl group on the carbon next to the OH. And alcohol C is tertiary because there's 3 alkyl groups that I've circled here attached to the carbon next to the OH. And alcohol D is classed as a secondary alcohol because there's 2 alkyl groups on the carbon next to the OH. So here are 2 more alcohols we'd like you to have a go at classifying. Pause the video, decide whether they're primary, secondary or tertiary, and then we'll go for the answers. So alcohol E is classed as a primary alcohol because there's 1 alkyl group attached to the carbon next to the OH, and alcohol F is classed as a secondary alcohol because there's 2 alkyl groups attached to the carbon next to the OH. So that concludes this video lesson. So after watching this video, you should now be able to explain how ethanol can be made from sugars using yeast in a process called fermentation. You should be aware of the uses of ethanol as a fuel in alcoholic drinks and as solvents. And you should be able to use the IUPAC rules to name and draw the structural formula of alcohols and be able to classify the alcohols as either primary, secondary or tertiary. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.